So, hello everyone and welcome to my seminar. Today I will be talking about image segmentation using the unit architecture. This topic plays a model role in computer vision, especially in the areas like medical imaging and autonomous systems. So, my name is Chinmay Kulkarni and I am excited to walk you through the topic in a simple and in a clear manner. So, before we get into segmentation, let's quickly understand what CVIP actually is. So, CVIP stands for Computer Vision and Image Processing, and the main goal of this is to enable the machines to understand images and videos like humans do. So, in CVIP, we perform various tasks like image classification, where we identify what object is present, object detection, and where we focus on the object location and segmentation. So these techniques are used in a wide range of applications from medical imaging to robotics and even in automation industries like self-driving cars. Now, coming to segmentation. Image segmentation is basically the process of dividing an image into different meaningful regions. Instead of just detecting or locating an object, segmentation goes deeper. It classifies every single pixel of the image. There are three major types: semantic segmentation, where all the pixels of a class are grouped together; instant segmentation, which separates even different objects of the same class; and panoptic segmentation, which combines both to give a complete understanding of the scene. So, you might be wondering, why do we need this segmentation when we already have detections or classification techniques? So, segmentation is important because it provides us very fine boundaries and pixel level details. For example, in medical imaging, doctors don't just need to know there is a tumor. They need to know that the exact shape, location, and the size of the tumor. So, and segmentation helps us to give the accuracy. It also helps in scene understanding, autonomous driving, satellite image analysis, and many other areas where detailed pixel information is always necessary. However, segmentation is not easy. Images often have overlapping objects, shadows, lighting variations, or noise. In many cases, the boundaries are unclear and difficult to detect. Since segmentation relies on pixel level precision, even small mistakes can impact the final output. So, we need a smart architecture that can handle all these challenges. And that's where UNet comes into the picture. So, UNet is a convolutional neural network architecture specially designed for segmentation. It was proposed in 2015 for biomedical image segmentation, and since then it has become one of the most widely used architecture for pixel level tasks. The name UNet comes from its U-shaped structure, which has an encoder on the left and a decoder on its right. So now, let me quickly explain how UNet actually works. On the left side, we have the encoder, which reduces the image size while capturing meaningful features. On the right side, we have the decoder, which brings the image back to its original resolution. One of the most powerful things about UNet is use of skip connections, where we directly connect the corresponding layers from the encoder to the decoder. This keeps the connections, help preserve spatial details that might get lost during its downsampling. And so, in the encoder, the network performs a couple of convolutional operations followed by the ReLU activation. After that, we apply the max pooling, which reduces the dimensions of the image. This process helps us to extract the deeper and more complex features. Basically, this path helps the model to understand what is exactly present into the image. So, in the decoder, we perform up convolutional or transport convolution to increase the image size back to its original resolution. The decoder then combines these unsampled features with the encoder features using skip connections. So, this path helps the model understand where the things are in the image and rebuilds to final segmentation mask. So, skip connections are extremely important into U-turn unit. During downsampling in the encoder, some fine details may get lost. So, by directly passing those features to the decoder, UNet ensures that the spatial information is preserved properly. This leads to much sharper and more accurate segmentation results. So, moving to the final output of the unit is a segmentation mask. These masks contain pixel-wise predictions, meaning each pixel is assigned a label like tumor or whether it is not tumor, road or non-road, land or water, and so on. Depending on the task, UNet can be used for binary segmentations or multi-class segmentations too. So, moving to train a UNet model, we generally use loss functions like dice loss or cross entropy loss. We train it on the dataset like medical images, satellite images, or even general datasets like COCO. To ensure performance, we use matrices like IOU, which is intersection over union, and dice score, both of which measures how well the predicted mask matches the ground truth masks. So that was all about the unit architecture. So moving towards an applications of unit. So UNet has a huge number of real-world applications. In medical imaging, it's used for tumor segmentation, organ segmentation, and disease detection. In autonomous vehicles, it helps to detect the lanes and road boundaries. In satellite imaging, UNet helps to classify lands, vegetations, water bodies, and more. In the robotics, it helps machines to understand their environment. Finally, coming to advantages of UNet. One of the biggest advantages of UNet is that it works amazingly well even with relative small datasets, which is very useful in the medical field. It also gives high accuracy and produces very clean segmentation results thanks to its skip connections actually. So as we saw the advantages of UNet network, so let's come towards the limitations. But UNet isn't perfect actually. Training is quite computationally expensive and it usually requires a GPU for good performance. It's also sensitive to noisy or low quality data. So pre-processing the images becomes very important in UNet. So, finally, to conclude, UNet has revolutionized the field of image segmentation. Its unique encoder decoder design with skip connections helps it achieve excellent pixel level accuracy. Because of its UNet continues to be widely used in medical imaging, robotics, automation driving, satellite imaging, and many other domains. So, thank you so much for listening. So, these are the references I used while preparing this presentation, including the original unit research paper by Robenberger ETL from 2015 and other standard CVIP resources. Thank you.